Hi guys, it's me Gokunath here. So guys, today we're going to see CBSE Term 2 integration practice problems. So let me start to solve guys. The first question is integral of dx divided by 1 plus tan x from pi by x to pi by 3. So this is the integral which we are having and we are supposed to solve this. So guys, how I'm going to solve this question is, I'm going to use your famous rule known as your King's rule. I'm going to use your King's rule and apply in this form of integral and I'm going to find the value of it. So what does your King's rule say? Your King's rule say that integral of f of x dx from a to b can be written as integral of f of a plus b minus x of dx from a to b. This is what our King's rule say, right? And that is something I am going to apply this integral and I am going to find the value of it by evaluating it. So how will I be using this King's rule is, before using King's rule, let me take this form of integral as I. I am taking this integral as I so that it will be helpful for the further purposes. Okay, so I am taking this integral as I now. Now I am going to use your King's rule. When I use your King's rule, what will happen is I need to find the value of f of a plus b minus x of dx. A plus b minus x of dx. So using King's rule, I would write the another I as integral of f of a plus b minus x of dx. F of a plus b minus x of dx will be nothing but f of pi by 6 plus pi by 3 minus x. F of pi by 6 plus pi by 3 minus x is f of pi by 2 minus x. F of pi by 2 minus x means just you need to put the value of x as pi by 2 minus x. I will repeat once again. F of a plus b minus x will be nothing but f of pi by 6 plus pi by 3 minus x, which will be nothing but f of pi by 2 minus x. In order to find the value of f of pi by 2 minus x, just put x as pi by 2 minus x in this integral. When you put x as pi by 2 minus x, what you will get? Integral of dx divided by 1 plus, if I put x as pi by 2 minus x, you would be getting as tan of pi by 2 minus x. Tan of pi by 2 minus x is nothing but cot x. Nothing but cot x, which is the basic trigonometric formula which you guys learned already, right? Tan of pi by 2 minus x will be cot x. These things you should know as your 12th standard. You must know these trigonometric formulas because in 11th itself you learn these things. So tan of pi by 2 minus x is cot x and the limits are pi by 6 to pi by 3. Now guys, the next step which I am going to do is a very simple step. I am going to write this cot x as 1 by tan x. Can't I write like that? I can write this cot x as 1 by tan x, right? That's a basic relationship which you guys learned in trigonometry. Again trigonometry, and this integral question is totally based on trigonometry. So this cot x can be written as 1 by tan x, which is the ratios which you guys already know. So 1 by tan x. So just I am writing this cot x which is there before, I am writing it as 1 by tan x. That's a basic formula of trigonometry. Now I am going to solve this denominator completely. When I solve this denominator completely, I am going to take the LCM in your denominator. When I take your LCM, what you will be getting? 1 plus 1 by tan x will be nothing but, listen carefully, 1 plus tan x divided by tan x, right? Correct now? Can't I write like this? Using your LCM only I am doing this. 1 plus 1 by tan x can be written as 1 plus tan x divided by tan x. It's a basic solving of your expression or the fractions which you guys learned in your lower grades. So 1 plus 1 by tan x can be written as 1 plus tan x divided by tan x. That's what I am doing. Now, as I am having division in your denominator, I can take this tan x to the numerator. Correct now? If I am having division in your denominator, I can take to the numerator because these are all the things which you will be doing for every sort of question, right? So that's a simple steps which I am doing. So this I can also be written as integral of same limits only, pi by 6, pi by 3. Now I am going to take this tan x as that is in division, I can take to the numerator. When I take like that, I will get tan x of dx divided by what will be left in the denominator? 1 plus tan x. Just I'm taking your tan x to the numerator as it is in division in the denominator. So 1 plus tan x, this is what I'm having. This is a new form of integral which we got using your King's rule. But what is the need to use your King's rule? What is the purpose to use your King's rule? The reason we began using King's rule is to make your integral easier. Even though I use King's rule in this integral, again I'm getting a complicated form, right? I'm not getting an easy integral. Even though I use King's rule, again I'm getting a complicated form of integral or a difficult form of integral where I have so much ratios like your tan x. So what would I do next? The thing you can do next is try to add up these two i's. That's the best method, guys, because I have seen those questions which upholds your King's rule. Mostly they will add these two integral when your new form of integral is not easily integrable, or when it looks very complicated form. So I'm going to add these two integral. When I add these two integral, I will be getting I plus I. These two i's I'm going to add because your f of a plus b minus x is looking complicated. So second option is add these two i's. When you add these two i's, what you will be getting is 2y will be equal to, just I'm adding these two integral, this integral and this integral. When I add, limits are same, so I can directly add the inside value. What are your limits? Pi by 6 to pi by 3. Limits are same, so I would directly add the inside value. When you add the inside value, what you will get is 1 plus tan x. The numerator will be getting 1 plus tan x. As the denominator is same for both the integrals inside value. As the limits are same, I can directly add the inside value. Now, for both the inside value and the denominator, I am having the same expression, which is 1 plus tan x or 1 plus tan x. So, I would directly add your numerator. So, divided by 1 plus tan x of dx. Why I am getting 1 plus tan x in the numerator? Because I am adding this two integral. If I have dx in the numerator of this integral, that means I am having 1 in the numerator. That and all you should know already. So, 1 plus tan x will be 1 plus tan x of dx. From pi by 6 to pi by 3, this will be 2y. Now, you can cancel out this 1 plus tan x and 1 plus tan x, and such a easy, right? It becomes such a easy form. That is why I told try to add these two integral. When you do like this, you will be getting 2y will be equal to, okay, I can write above, right? 2y will be equal to integral of 1 dx from pi by 6 to pi by 3. Now, what is integral of 1 dx? That is x from pi by 6. These are all I should not write because simple things, right? So, these are all I should not write. So, 2a will be equal to what? 2a will be equal to pi by 3 minus pi by 6. So, pi by 3 minus pi by 6 is nothing but pi by 6. So, I will write here. 2i will be equal to pi by 6 because pi by 3 minus pi by 6 is nothing but 2 pi minus pi by 6, which is pi by 6. So, your value of I will be nothing but pi by 12. Because 2y is only is equal to pi by 6, don't directly jump to answer like pi by 6. 2y is only equal to pi by 6. Your I will be nothing but pi by 12. Just say solve this definite integral, because integral of 1 dx from pi by 6 to pi by 3 is nothing but integral of dx is x from pi by 6 to pi by 3 will be pi by 3 minus pi by 6. So you will be getting it as 2y will be equal to pi by 6. If 2y is equal to pi by 6, I will be pi by 12. And that's all, guys. That's all about this question. Your answer is pi by 12. That's all about this question. Let us move on to our next question. Our next question is integral of dx should be 4 sin square x plus 5 cos square x plus 4 sin x cos x. So guys, this is the integral which we are having that is supposed to solve. So what I am going to do now is I am going to divide your cos square x on both numerator and denominator. That's the first step which I am going to do. When you divide cos square x on both numerator and denominator, what you will get is in the numerator when you divide cos square x, you will be getting it as 1 by cos square x. 1 by cos square x is nothing but your secant square x. Secant square x. Now, when you divide cos square x on your denominator, what you will get is 4 sin square x divided by cos square x. When you divide your cos square x on denominator, you will be getting 4 sin square x divided by cos square x, which is nothing but 4 tan square x. Why? Because this is a basic ratio which you guys learned in trigonometry even in 9th, 10th standard. So your sin theta by cos theta is equal to tan theta, and that is why I am writing it as tan square x. So 4 sin square x divided by cos square x will be 4 tan square x. Then plus of 5 cos square x divided by cos square x. 5 cos square x plus divided by cos square x will be nothing but 5 here. Then plus of 4 sin x cos x divided by cos square x. 4 sin x cos x divided by cos square x, I will divide here. 4 sin x cos x divided by cos square x. So when you divide, this cos x and 1 cos x will get cancelled and you will be left with cos x in the denominator. So 4 sin x divided by cos x is nothing but 4 tan x. Again the same in trigonometric formula, because sin theta divided by cos theta is equal to tan theta, which is the basic ratio which you guys learned in your 9th, 10th, 11th standard. So 4 sin x divided by cos x will be nothing but your 4 tan x. 4 tan x. This is what we got. Now I'll take the duster. So this is what we got when we divide your cos square x on both numerator and denominator. So guys, the next step which I'm going to do is, here I need to write the dx, right? Yes. So dx. So the next step which I'm going to do is, I'm going to do your substitution. But before that, there's one important method to do. Before going to your substitution, there's an important method to go. So what's the method is, can't I write this integral as, 1 minute, can't I write this integral as 1 by 4 into integral of secant square x? Listen carefully guys, because it's a very important part. Before going to your substitution, I need to do something. So can't I write this integral as 1 by 4 into integral of secant square x dx? What I will write in denominator? That is what is very important. I can write this as tan x plus 1 by 2 whole square plus 1. Can't I write like this? Can't I write like this? I can write this integral as 1 by 4 into integral of secant square x of dx. In the denominator, I would write it as tan x plus 1 by 2 whole square plus 1. Because guys, when you substitute this value, when you evaluate this value, when you multiply 4 in the denominator just by multiplying 1 by 4 with the inside value, you will be getting 4 tan square x plus 5 plus 4 tan x. You do your rough work. These are all the basic things which you are supposed to know. If tan x plus 1 by 2, it is whole squared using a plus b whole square formula, and when you add 1 to it, and when you multiply this 4 with this value, with this expression, you will be getting 4 tan square x plus 5 plus 4 tan x. Okay, that is what I did. Now I can do your substitution. That is why I told there is something which I am supposed to do before your substitution. Now I can do your substitution. So what I am going to do is, I am going to take your tan x plus your 1 by 2 as your t. Then take tan x plus 1 by 2 as your t. Then your dt will be nothing but secant square x. Not only that, the dx will be nothing but your dt. Correct now? If I put tan x plus 1 by 2 as t, that means a substitution, you will be getting secant square x of dx as dt. What is your dt? The differentiation of t. The differentiation of your tan x plus 1 by 2. Differentiation of tan x is secant square x. Differentiation of 1 by 2 is 0, because differentiation of any constant is 0, as derivative of your k is 0. These are all things which you guys learned even physics. So I can write this dt as secant square x of dx, because dt is a differentiation of this value. Now when I use this substituted t and dt, what you will be getting, what will be the new form of integral is 1 by 4 into dt divided by t square plus 1. This is what I will be getting, right? Correct now? So So when I do like this, 1 by 4 into integral of secant square x dx divided by tan x plus 1 by 2 whole square plus 1 can be written as 1 by 4 into integral of dt divided by t square plus 1 using this substitution, as your tan x plus 1 by 2 is equal to t and secant square x dx is equal to dt. So in the numerator I am having secant square x dx and that is why I am writing it as dt. And the denominator I am having tan x plus 1 by 2 which is t. So I am writing as t, then I am having whole square, that is why it is t square, then plus 1. This is a basic thing which I am doing. Now I can rub this guys because I don't need it now. Now I will write it as t square plus 1 as 1 plus t square. Why I am writing like this means there should be a particular order which you guys are supposed to know in order to use your integration of dx by a square plus x square formula. Okay, I need to use your integration of dx by a square plus x square formula. That is why I interchanged it. Just the mirror image or a reflection you can see. So t square plus 1 I wrote it as 1 plus t square. Why I wrote like that? You will be doing after telling one formula. Okay, so what formula is I'm going to use a formula which is integration of dx divided by a square plus x square is equal to 1 by a of tan inverse of x by a plus some constant. This is what the formula I am going to use now. As we know, your x should be a variable and a is a constant. That is the reason why I replaced it as 1 plus t square. I hope you guys would understand what is the reason behind interchanging it. I interchange this t square plus 1 as 1 plus t square. Why? That is to use this formula, as your a is nothing but a constant which is 1. A is a number, or we can say it as constant which is 1, and x square will be a variable t. That is the reason why I interchange your denominator as 1 plus t square. Now when you use this formula, I will rub this. When you use this formula, what you will be getting is it's equal to 1 by 4 of integral of dt divided by 1 plus t square. Integral of dx by a square plus x square is equal to 1 by of tan of x by plus some constant. So I will write this one as 1 square to cooperate with this formula, because I am having a square plus x square. So here also I should have some square number plus some square number, correct, right? So correct now. So 1 square will be your a square, x square will be your t square. So using the formula 1 by a will be nothing but 1 by 1, because your a is 1. So 1 by a will be 1 by 1. So 1 by 1, nothing gonna happen, so I don't need to write that. Next, into tan inverse of x by a. X by a will be nothing but your t divided by 1. Because your x is nothing but your t and a is nothing but your 1. That is why your x by a is t by 1. T by 1 is t1d. Then plus some constant. I hope you guys would understand what is the reason behind interchanging your denominator and using this formula, and how I wrote this a as 1 square and how I wrote this x square as t square. I hope you guys would understand that. So just I use this formula. So 1 by a is 1 by 1, which is 1 by 1, so I don't need to write that. Into tans of x by will be nothing but t by 1, so tans of t plus some constant, just like by using this formula. So integration of dx by a square plus x square is equal to 1 by of tans of x by plus some constant. Please remember it. Now I can rub this, guys. So what will be your new answer is 1 by 4 into tans of t. What is your tans of t? Tans of t is nothing but tans of t. T is tan x plus 1 by 2. So tan x plus 1 by 2 plus some constant, and that's the answer for this question. Just I put the value of t, which is tan x plus 1 by 2, right? So before few minutes only I was substituting the value as tan x plus 1 by 2 as t and secant square x dx as dt. So I am putting that value, which is the value of t, in your tans of t term. So I will be getting 1 by 4 into tans of, what is the value of t? Tan x plus 1 by 2 plus some constant. That's the answer for the question. So that's all about this question. Let us move on to our next question. Our next question is integral of sin x plus cos x whole square divided by root of 1 plus sin 2x from 0 to pi by 2. So this is a question which we are having. So guys, what is the clue for this question is, You need to completely solve this denominator, which is this particular expression root of 1 plus sine 2x. You need to completely solve this denominator and then only you can find out the value of this integral. So how can you solve this question is, listen carefully, we are having integral of sin x plus cos x whole square. Guys, now itself I am saying I am not going to use your substitution and all. Okay, I am going to use something which you guys already know, that is your trigonometric formulas. Okay, so I am going to use your trigonometric formulas only. So the denominator, what we are having, root of 1 plus sine 2x. What is this 1? This 1 I can write it as sin square x plus cos square x, right? That's a basic trigonometric formula of the Pythagorean identity which you guys learned in trigonometry. So this 1 can be written as sin square x plus cos square x. That's a Pythagorean identity which you guys learned in your trigonometry. So I can write this 1 as sin square x plus cos square x, because sin square x plus cos square is equal to 1, Pythagorean identity. Now next I am having plus of sin 2x. What is this sin 2x? Again your trigonometric formula. I am going to use your double angle formula. Your sin 2x is nothing but 2 sin x cos x. This is the double angle formula which you guys supposed to know. Because as you guys are 12th standard, you crossed your 10th standard, you crossed your 11th standard. So of course you should know this formula, which is the double angle formula. So I just wrote 1 as your sin square plus cos square x, Pythagorean identity, and sin 2x as 2 sin x cos x, that's your double angle formula. Because sin 2 theta is equal to 2 sin theta cos theta. Cos 2 theta is equal to cos square theta minus sin square theta. You guys know that, right? So that's what I am using. So sin 2x is equal to 2 sin x cos x. Now, what is the reason we can writing all those formulas? Is that to show my knowledge? Is that to show my knowledge? Is that to show that I memorize all the formulas? Definitely not. That is one biggest reason behind that. So guys, listen carefully. I need to write the limits, right? 0 to pi by 2. So 0 to pi by 2. Now, what is this? Sin square x plus cos square x plus 2 sin x looks like a form of a square plus b square plus 2ab. Correct now? Sin square plus cos square x plus 2 sin x looks like a form of a square plus b square plus 2ab, which is a plus b whole square. See, right? Using the formula, how easy it is becoming without even using your substitution. How I am making this integral easier. That is what the beauty of the integration. So the numerator I am having sin x plus cos x whole square then divided by root of sin square x plus cos square x plus 2 sin x cos x is a square plus b square plus 2ab, which is a plus b whole square. What is your a? Sin x. What is your b? Cos x. Because sin x plus cos x whole square only will give us sin square plus cos square x plus 2 sin x cos x. So I can write as a plus b whole square, which is your sin x and plus cos x whole square, where your a is sin x and b is cos x. So ax plus b whole square is equal to a square, which is sin square x, b square plus b square, which is cos square x, plus 2ab, which is 2 sin x cos x. And that is the reason why I converted this 1 as sin square plus cos square x and sin 2x as 2 sin x cos x. It's not like conversion, that's a formula. Okay? That's a formula and it's obvious. Now, root of sin x plus cos x whole square will be nothing but what? Root of x square will be what? Root of x square will be root x only. Root of x square will be x. So root of sin x plus cos x whole square will be sin x plus cos x. How simple is it, right? How simply I'm doing this. That's what the beauty are supposed to know. So root of sin x plus cos x whole square will be sin x plus cos x. Why? Because, for example, if I say there's a value like y square. So root of y square will be y only, right? Correct now? Root of y square will be y, or sometime you will be saying plus or minus y. Don't do that much difficulties here. Just do the basic things. So root of sin x plus cos x whole square will be sin x plus cos x. That is what I am going to write. So root of sin x plus cos x whole square will be sin x plus cos x. That's the basic thing. Because I am having square inside. So So root of sin x plus cos x whole square will be sin x plus cos x. Now sin x plus cos x whole square divided by sin x plus cos x whole square, these two will get cancelled and you will be left out with 1 sin x plus cos x. 1 sin x plus cos x. I hope you guys will understand what I am trying to say. Sin x plus cos x whole square divided by sin x plus cos x whole square, your denominator will be cancelled as sin x plus cos x and numerator sin x plus cos x will get cancelled and you will be left out with 1 sin x plus cos x, not that one. I'm saying that a particular expression sin x plus cos x, because sin x plus cos x whole square divided by sin x plus cos x, where your denominator will get cancelled with sin x plus cos x and your numerator will get cancelled with sin x plus cos x. Here x, right? Yeah. Sin x plus cos x, and you will be left out with 1 sin x plus cos x in your numerator. Now it's a very easy question. Listen carefully. So what you are going to do is I'm having integral of 0 to pi by 2. So sin x plus cos x whole square divided by sin x plus cos x, sin x plus cos x. Just 1 sin x plus cos x will get cancelled on both numerator and denominator. This is what I will be left out. Now split this integral, guys. Here there should be dx, right? Here also there should be a dx. Okay, I forgot to put the dx. If in the previous expression, if I forgot to put the dx, don't blame me. That may be mistakenly, but it's not a problem. Okay, so I'm putting dx now. So when I split it, what you will get is integral of sin x from 0 to pi by 2 plus integral of cos x from 0 to pi by 2. This is what we are having. Now I will rub this. Now when I rub this, just try to solve this different integral. What is integral of sin x? That is minus cos x. Integral of sin x is minus cos x. When you solve this definite integral, you will be putting a box like this. The lower limit is 0 pi by 2. Then plus of integral of cos x is nothing but your sin x. Then from 0 to pi by 2, this is what you will be doing. Now what you are supposed to do is minus cos x from 0 to pi by 2 plus sin x from 0 to pi by 2. What you will be doing is just try to solve this definite integral, because integral of sin x is minus cos x, integral of cos x is sin x. Now I'm having this 0 to pi by 2. You need to solve these limits. So when you need to solve this limit, what you will do is cos of pi by 2. What is cos of pi by 2? Cos of pi by 2 will be nothing but 0. Okay, so cos of pi by 2 will be 0. So cos of pi by 2 is 0 means I will be having 0 minus of cos of 0. Cos of 0 is 1. So minus of minus 1. Then plus of sin x from 0 to pi by 2, where you will be having sin pi by 2. Sin 90 degree is nothing but your 1. So plus 1 minus 0. So this will be nothing but 1 plus 1 which is equal to 2, and that's the answer. I will say what I did. Minus cos x from 0 to pi by 2 will be nothing but first put x as your pi by 2 just by solving. This is a method of solving a definite integral using your limits. So cos of pi by 2 will be nothing but 0. That is why I wrote 0 here. Then minus you need to put. Why? Because that is a method to solve your limits. So minus of cos of 0. What is cos of 0? Cos of 0 will be nothing but 1. So cos of 0 is 1. Then you should put minus 1 here, because I am having minus of cos x. Then plus of sin x from 0 to pi by 2. Here also same limit solving. So sin pi by 2 will be 1 minus 0. So 0 minus of minus 1 will be 1. 1 minus 0 will be 1. So 1 plus 1 2, and that's the answer for this question. That's all, guys. Let us move on to our next question. Our next question is integral of sin cube 2x divided by cos to the power 5 of 2x of dx. This is the integral we are having. So guys, how I am going to solve this question? Listen carefully. What I am going to do is, we are having integral of sin cube sin to the power of 3 of 2x divided by cos to the power of 5 of 2x. This is something I am having now. Now I am going to split this cos to the power of 5 2x as cos cube 2x into cos square 2x. Can't I split like this? Definitely I can split like this because the power is 5. So cos power 5 of 2x can be written as cos cube of 2x into cos square of 2x. Because 3 plus 2 is 5, I am having the power correctly using a laws of exponents. So cos to the power 5 2x can be written as cos cube 2x into cos square 2x. What is the reason we can writing like this? Listen carefully. Now I am going to write this cos square of 2x as 1 by secant square of 2x. Can't I write like this? I can write that cos square of 2x as 1 by secant square of 2x. How? That's by your trigonometry again. So your trigonometric formula, that's the ratios. So your cos theta is equal to 1 by secant theta. So your secant theta your cos theta is equal to 1 by secant theta, and that's why I'm writing like this. How I frame that means, as we know, your secant theta is equal to 1 by cos theta. If secant theta is equal to 1 by cos theta, then definitely your cos theta will be 1 by secant theta. So cos square of 2x will be 1 by secant square of 2x. That's by the relationship. That's the relationship which I frame by the formula of that is cos theta is equal to 1 by secant theta. So cos square of 2x can be written as 1 by secant square of 2x. Now, as I am having division here in the denominator, so I would take to the numerator because I am having division denominator. Because if I anyway divide, then I would take to the numerator only, and that's what I am doing now. So when I take this secant square 2x as a numerator to the numerator, what you will get is into secant square of 2x of dx you will be having. I forgot to write the dx. So this is what I am having. So just I wrote 1 by secant square of 2x to the numerator. Just I took it to the numerator. Why? Because it is in the division of the denominator, and that's why I took it to the numerator. Now what I am gonna do is, what is this sine cube of 2x divided by cos cube of 2x? Sine cube of 2x divided by cos cube of 2x will be nothing but tan cube of 2x, and that is the reason why I splitted your denominator as cos cube 2x into cos square of 2x. Okay, in order to make this form of expression as your tan cube of 2x, I splitted this denominator as cos cube of 2x into cos square of 2x. So sine cube of 2x divided by cos cube of 2x will be nothing but tan cube of 2x. Nothing but tan cube, right? Tan cube of 2x. Then what I am having into secant square of 2x of dx. This is what I am having. And guys, don't tell that I am pronouncing wrong, because guys, it is only powers, right? So sometimes it will be like a pronunciation wrong. So tan cube of 2x into secant square of 2x. Correct? Okay. So tan cube of 2x into secant square of 2x dx. Because sine cube of 2x will be cos cube of 2x can be written as tan cube of 2x just by your trigonometric formula, because sine theta by cos theta is equal to tan theta. That's what I am doing. So sine cube of 2x by cos cube of 2x will be tan cube of 2x. Then I am having this secant square of 2x, and that's what I am doing now. Now I am going to do your substitution, which you guys are more familiar with. So I'm going to take tan 2x as t. When you take tan 2x as t, then your dt will be nothing but 2 secant square of 2x or dx will be nothing but your dt. Correct now? If I put your tan 2x as t, which is a substitution for the value, when you put tan 2x as t, then you will be getting 2 secant square of 2x as dx as dt. How? Because I am taking this tan 2x as t for your substitution. When you take tan 2x as t, then your dt will be the differentiation of this, which is 2 secant square of 2x of dx will be your dt. When you use a substitution, you will get tan cube of 2x. Tan 2x as t means, and tan cube of 2x will be t cube. Correct now? Tan of 2x is equal to t means, then tan cube of 2x will be t cube. Then into secant square of 2x of dx. Should I directly write it as dt? Don't do that mistake. Your dt is 2 secant square of 2x of dx. But here I am only having secant square 2x of dx. I am not having 2 in it. But in here, your dt is 2 secant square 2x of dx, but this is secant square 2x of dx. So I can't directly write it as dt, but rather I can write it as dt by 2. Then only you will be getting as secant square of 2x dx. Because 2 seconds, 1 minute guys. Okay. So 2 secant square of 2x of dx is only dt, but secant square of 2x is only we are having. So I'm not having 2 in this form of expression. That is why I divided your dt by 2. Now I'm going to take this 1 by 2 to the outside. When I take, I will having 1 by 2 into integral of t cube into dt. So integral of t cube will be nothing but half into t cube integral, which is t to the power of 4 divided by 4 plus some constant, right? So I will rub this. When I rub this, so integral of t cube into dt will be equal to half into integral of t cube is nothing but t to the power of 4 divided by 4 plus some constant. Now half into t cube divided by 4 will be nothing but t power 4 divided by 8 plus some constant. So what is your t? T is nothing but tan 2x. So tan 2x divided by 8 plus some constant is the answer for this question. Okay guys. So what I did is just use your integration formula. So half into integral of t cube of dt. Integral of t cube is nothing but t to the power of 4 divided by 4. This is a basic integration formula. So half into t to the power of 4 divided by 4 plus some constant, which will be nothing but 2 into 4 in the denominator. So t to the power of 4 divided by 8. 2 into 4 is 8 plus some constant. Then I put the value of t, which is tan 2x. So tan 2x to the power of 4. I forgot to put that, right? Tan 2x is only t. Then your t to the power of 4 will be tan to the power of 4 of 2x. Okay guys, sorry for this mistake. If tan 2x is t, then t to the power of 4 will be tan to the power of 4 of 2x divided by 8 plus some constant. And that's the answer for the question. So that's all about this question. Let us move on to our next question. Our next question is integral of e power x of log x plus 2 by x minus 1 by x square of dx. So guys, how I am going to solve this question is a very easy question if you know the properties of integration. And guys, it's a JEE mains question which can be expected in your CBSE term 2. So guys, what I'm going to do is, I'm going to split this 2 by x as 1 by x plus 1 by x. I'm going to split this 2 by x as 1 by x plus 1 by x. When I split like that, you will be getting it as log x plus 1 by x plus 1 by x. You will be able to know in few minutes what is the reason behind splitting like this. So minus of 1 by x square 1 by x square of dx. This is what you will be getting when you split this 2 by x as 1 by x plus 1 by x, just I'm splitting like that. Now I'm going to take this log x plus 1 by x as one part and this 1 by x minus 1 by x square as another part. Just I'm taking this log x plus 1 by x after dividing 2 by x as 1 by x plus 1 by x. After splitting it, I'm taking this log x plus 1 by x as one part and 1 by x minus 1 by x square is another part. That's what I'm doing. When I take like that, I can split the integral as integral of e power x of log x plus 1 by x plus integral of e power x of your 1 by x minus 1 by x square. This is what I am doing. So what I did is, guys, I need to write the dx here. Okay, dx. So what I did is, just I took log x plus 1 by x as one part and 1 by x minus 1 by x square another part. So log x plus 1 by x is your first part and 1 by x minus 1 by x square is second part. When I take like that, after splitting your into parts, I split the integral also. I split the integral as integral of e power x of log x plus 1 by x, which is integral of e power x of log x plus 1 by x. I split it like that. Again for here also I split it as integral of e power x of 1 by x minus 1 by x square of dx. Just I split the integral based on the respective parts. Now, do you guys know one formula, right? It's properties of your integral, which is integral of e power x of f of x plus f dash of x of dx can be written as e power x of f of x plus some constant t plus some constant c, and this is the property that I am going to use now. So integral of e power x of f of x plus f dash of x of dx can be written as e to the power of x of f of x plus some constant c. Okay, so this integral of e power x of f of x plus f dash of x, where f dash of x is the derivative of this f of x, this can be written as e power x of f of x plus some constant c. Here, integral of e power x of log x plus 1 by x. We know that your 1 by x is the derivative of log x, right? So I need to log x here, right? I need to write log x here. So we know that your 1 by x is a derivative of log x. So from this you would say that your log x will be your f of x and 1 by x will be f dash of x. So this can be written as e power x of f of x. F of x will be log x because log x is your f of x and f dash of x is 1 by x plus of integral of e power x of 1 by x minus 1 by x square. 1 by x minus 1 by x square, we know that your 1 by x's derivative will be minus 1 by x square, right? Minus 1 by x square is the derivative of 1 by x. The differentiation of 1 by x only will give us minus 1 by x square. So we would say that your 1 by x will be f of x and minus 1 by x square will be f dash of x. F of x will be 1 by x and minus 1 by x square will be f dash of x. So you can write it as e power x of f of x. Your f of x is 1 by x then plus some constant. This constant is for both these integral. This constant is for both these integral. Even though I have multiple integrals in the question, I can write one constant itself. That constant is the sum of all the constant of those multiple integrals. So what I just used is, I just use your property of your integration, which is integral of e power x of f of x plus f dash of x of dx can be written as e power x of f of x plus some constant c. So here we know that your 1 by x is the derivative of a log x, which is the differentiation of log x. So your log x will be f of x, 1 by x will be f dash of x. So this e power x of f of x f dash of x will be nothing but e power x of f of x, which is log x, plus of e power x of 1 by x minus 1 by x square. We know that your minus 1 by x square is derivative of 1 by x. So 1 by x is f of x minus 1 by x square will be f dash of x. So this is nothing but e power x of f of x plus f dash of x, which is e power x of f of x, where f of x is 1 by x. So e power x into 1 by x plus some constant. This constant is for all those multiple integrals. So that's all guys, and this is the answer for this question. So main part is this property, and we are having another property like your x into f dash of x plus f of x. Those properties are also important. That's all guys. That's all about these questions, and that's all about these questions on today's session. So that's all guys. Thank you. Make education simple.